So here we are. We're going to talk real quick about levers. I'm going to splice a couple of videos together and give you some data to use for your Simple Machines investigation. We've got a lever here set up as a first class lever. We've got an axle in the middle, which acts as our fulcrum, our pivot point. A resistance force on one end and an effort force. This is that force gauge. I will be pulling on this to apply the effort force. I'm going to handle the data collection for all of you, so you can use the same, and it stinks we got to use the same numbers, but that's what's got to happen. Otherwise this will take 9 weeks to do one activity. So first I've zeroed out my force gauge. I'm using a program called Logger Pro, and I'm also screen recording what's happening here on Logger Pro. I'll hopefully be able to splice these two videos together nicely so you can see them. You can see that I have really close to 0 newtons of force. I've zeroed it with the force gauge, force sensor hanging already, so I'm not accounting for the mass of this. So what I'll do now is I'll click collect, and then I will lift up my lever. Hold it at static equilibrium, and I'm getting about 1.92, 1.95 or so newtons of force. My test is over. It's a 10-second test at 2 samples a second. So what I should have is a whole bunch of time and force readings. Okay? And you can see by the graph, you can also see over here, I'm looking at my forces. I'm looking for the highest one, 196, 193, 194, 195. I would say maybe like 194, 1.94 would be an acceptable number. You obviously don't want the highest one. You obviously don't want the lowest one. So I'm sort of averaging the upper ones in my head quickly. So 1.94 newtons. That would be my effort force for this specific application. So we're working in newtons here. We're also going to keep that consistent with the metric system. So I'm going to measure in centimeters and then convert to meters because we don't have newton centimeters, we have newton meters. So my distance from my fulcrum to my resistance is, I'm going to say 18.5 centimeters. So my FR is 18.5 and my FE, we're going to say 26. So 26 or 0.26 meters, right? So you now have all of the information you need to know to complete activity 1 of the Simple Machines investigation. I'll hit pause on the video and we will set up the next lever. So now I've quickly created a second class lever. Our resistance force is at this point in time 23 centimeters away from our fulcrum, and our effort force is 44 centimeters away from our fulcrum. So what I'll do at this point, we have a 5 Newton resistance force. I'm going to use the same Logger Pro software that we did before to calculate, or measure rather, not calculate, but measure the resistance force. So first thing I'm going to do here is zero this out. I'll hit click collect, and now we can see that as I'm holding this in static equilibrium, I have roughly 3.52, 3.54 newtons of effort force. So for the second problem, the second class lever, we're going to use 3.54 for our effort force. And the last one here that we need to do is, I need to switch this around. It's a little tricky sometimes. So what I've got now is I've got another lever. This is a third class lever. Third class lever. I've got a distance of 24 centimeters between my fulcrum and my effort force, and I've got a distance of 44 centimeters between my resistance force and my fulcrum. So quick time for prediction. What do you think is going to happen if when I lift this up and record the amount of force that it's going to take to lift this 5 Newton weight up? So let's go ahead and I'm not going to apply a whole lot of pressure, but I am going to zero this out. I'll hit collect, simply balancing it with my hand, and I'll lift it up, and you can see that it's taking 8.5, I would say like 8.6 or so newtons of force to hold that up. So more force is required with a third class lever because it has a mechanical advantage of less than 1. It will always have a mechanical advantage of less than 1. So there are your numbers that we're going to use for our Simple Machines levers investigation. We have a force here on the third class lever of, we're going to go ahead and say 8.6 newtons. And our two distances, which we just talked about, were 24 centimeters to the effort, 44 centimeters to the resistance, and the resistance is 5 newtons. So use those numbers for your calculations, folks.